Hello students, in continuation of our material science cubic systems, crystal structure, today we will see what are some symmetry aspects present in cubic crystals. Okay, cube, any geometric structure will have some symmetries around it. Okay, right, means every structure will be symmetric in some aspects. What are those symmetry aspects? Okay, from that what we can derive, we will see today. Okay, now you take a cube. Okay, all sides are equal. Okay, all angles are 90, 90, 90. A cube is like this. Now, consider this point, which is the body center. Consider this point, which is the body center. Okay. From that body center, the body center is at same distance from all the 8 corners. What is the length of the body diagonal? Right? We have seen it is root 3a. So, body center will be at a distance of root 3a by 2. Okay. So, all 8 corners will be at the distance of root 3a by 2 from the body center. All 6 faces are at a by 2 distance from the body center. Okay, body center is the most symmetric point in the cube. You invert the cube about the body center, okay, in any direction, you will get the same picture. Okay, you can rotate like this, or you can rotate like this, or you can rotate invert like this, or invert like this. Okay, after that operation, cube appears same as before. Okay, there won't be any change in the appearance of the cube. So, body center is the most symmetric point in the cube. I'll call it as the center of inversion. I'll call it as center of inversion. This is a very, very crucial aspect of cubes. Okay. Again, we'll come back to this point at the end of, in the last topic of dielectric materials. Okay, we'll talk about some special dielectric materials like ferroelectric materials, piezoelectric materials, and pyroelectric materials. Okay, which are extremely used. You don't know that whether you are using this. Our cigarette, our gas stove lighters. Okay, our ignition systems in motorcycles. You press a button, the motorcycle is starting now. Earlier it was not like that. You have to kick it. Okay, right? Cars were having ignition, but not motorcycles and scooters. Now everywhere we are using those ignition systems. Okay, we use some special materials, ferroelectric materials. Okay, right? In that pyro, and ferroelectric materials will be there. Okay, right? Now, what are those materials? In what way they are different? It is this center of inversion which decides whether the material is, right, piezoelectric or not. Okay, that I'll come back to this, but remember this point. Okay, right? So, this point is a symmetry aspect present in the cube. Right? Now, what is, it is like this. Okay, cubic system is there. I'll just ask one question only, whether it is having center of inversion or not. Okay, yes, if it is having center of inversion, it is yes. There is no question of one object becoming symmetric about 2 different points. Okay, a structure will have center of inversion or will not have center of inversion, that's all. Okay, right? It is not that the cube is what you call it, sphere is there. Okay, sphere is a sphere, center of the sphere becomes the center of inversion for the sphere. Okay, this structure has center of inversion. This structure also has center of inversion. Something else which is like this, right, is not having center of inversion. That's it. Okay. But how many centers of inversion? No, that question will not arise at all. Any one geometric shape cannot be totally symmetric about 2 different points. Okay, cannot be totally symmetric about 2 different points. Okay, right. So whether now all that I want is what, whether this structure, cubic structure, is having center of inversion or not. Yes, it is having center of inversion. What is the center of inversion? Body center is the center of inversion. Body center is the center of inversion. Okay. So that is one symmetry aspect of what you call the cube. Okay. The body center of the cube is the most symmetric point in the cube. So it is known as center of inversion. So that is one symmetry aspect. Okay. Next one. Next one. Again, you draw one cube. Okay. By this time, you should become perfect in drawing perfect cubes. Okay. Now, look at this plane. look at this plane. That plane is passing through the midpoint of the top face. It is passing through the body center. It is exactly bisecting the bottom face. Okay, right? This plane is known as a symmetric plane because you can, what you call, reverse the cube about this plane, cube appears same. Okay, if I am reversing without you seeing, if I reverse the cube about this plane and you have not observed me rotating, right, you will not understand whether I have rotated or not. Because, right, the cube exactly looks as it was before. Okay, so this is called one bilateral plane of symmetry. Okay, it is called one bilateral plane of symmetry. Okay, bilateral plane of symmetry. Okay, now this cube is having this bilateral plane of symmetry. It is nothing but when you reflect this part of the cube in the mirror, you will get the other part of the cube. Okay, so these bilateral planes are about reflection. You cut this part of the cube and put one mirror here. You can observe what you call the remaining part as an image of this cube. The cube appears perfect. Okay, so this is called a bilateral plane of symmetry. Okay, the cube is symmetric about this, about the rotation. Okay, reflection about this plane, the cube is symmetric. Now, how many such planes are possible in this cube? Okay, you can cut the cube into two equal parts, not only like this, but you can cut the cube into two equal parts like this also, isn't it? There is no difference between this plane and this plane and this plane. So, this one is also bilateral plane of symmetry. Okay, it is also cutting the cube into two exactly equal similar parts. Okay, and you can as well cut the cube horizontally like this into two equal parts like this. Okay, so this is also a bilateral plane of symmetry. So a cube has how many bilateral planes of symmetry? Okay, it is having three bilateral planes of symmetry. Okay, so number of bilateral planes of symmetry. Number of bilateral planes of symmetry equal to 3, I will write. That is not the question of center of inversion I told. Okay, a body will have center of inversion or will not have center of inversion. If something is having center of inversion, there is no question of how many centers of inversion are there. No, we should not, it cannot be like that. Okay, body can have only one center of inversion or not. But here, bilateral planes of symmetries are how many are there, right? All planes are identical. All planes are cutting the cube into two exactly similar parts. So how many are there? 3 are in number. Now, is this the only way of cutting the cube into two identical parts? Just tell me, just guess for some time. Okay, is this the only way I can cut the cube into two symmetric parts? Okay, two similar parts? No. Okay, I can as well cut the cube in a different way. I can as well cut the cube in a different way like this. Okay. Again, draw one cube. Right? Now, earlier for bilateral planes of symmetry, we have cut the cube like this. Now, I can cut the cube into two similar parts like this also, isn't it? Diagonally also I can cut. Diagonally also I can cut. Only thing is like a two triangular shaped parts will come, that's all. But the cube is cutting this. Okay, this plane is cutting the cube into two similar identical parts. Okay, right? This is not a bilateral plane of symmetry. This is known as a diagonal plane of symmetry. This is known as a diagonal plane of symmetry. Okay. Now, is it the only way, only diagonal plane possible in the cube? Can't I cut the cube into two such similar parts in more different ways? Okay, you can immediately identify that there is one more way of cutting also. Even this plane also will cut the cube into two identical triangular shaped or pyramid shaped cubes. Okay, right? So, this is another diagonal plane of symmetry. Okay, this is one diagonal plane of symmetry like this. How many diagonal planes of symmetries are possible? Means number of diagonal, okay, diagonal planes of symmetry. Number of diagonal planes of symmetry equal to. Now we have to explore how many possible ways are there. Now, for each diagonal plane, remember, right? I'm taking the help of two edges. This is one edge and this is one edge. Okay, one diagonal plane is associated with two edges. This diagonal plane is also associated with this edge and this edge. Means to draw one diagonal plane, I'm taking the help of two edges. In general, what's called totally how many edges will be there in a cube? Totally how many edges will be there in a cube? Cube has, in the very beginning I told you, cube has 6 faces, 8 corners and 12 edges. Okay, for each diagonal plane, I'm taking the help of two edges, and there are 12 edges in the cube. 12 edges in the cube means how many diagonal planes of symmetry I can draw? 6 diagonal planes of symmetry I can draw. Okay, this will also be one diagonal plane of symmetry. Similarly, I can start from here and end in this one. I can cut the cube like this. Similarly, I can start here and end and this edge, okay, like this, and I can start from this edge and come to this edge like this. Okay, totally there are 6 diagonal planes of symmetry. Each diagonal plane requires 2 edges. There are 12 edges in the cube, so I can draw 6 diagonal planes of symmetry. So number of diagonal planes of symmetry equal to 6, I write. Number of diagonal planes of symmetry equal to 6 we can write. Okay. This is known as planar symmetry. Okay, in different ways. In how many different ways the cube is symmetric with respect to planes we have seen. With respect to point, okay, center of inversion, that is one. And with respect to planes, there are actually totally 9 planes. Of them, 3 are bilateral, 6 are diagonal planes of symmetry. Now, I will see, right, the cube is symmetric in what aspects? One point is over, plane is over. Now I will talk about a line, in what ways or how many ways the cube is symmetric. Okay, that's called axial symmetry. That's known as axial symmetry. I will take one cube. Though this is not a cube, sorry. Okay, though this is not a cube, imagine that this is a cube. Now I'll imagine an axis passing through the cube like this, passing through the midpoint of the opposite face, passing through the body center and coming out from the midpoint of the bottom face. Now, if this is a cube, I can rotate the cube like this. Okay, right? In how many ways it appears the same as before? Means if what is that symmetry means? If you perform an operation, if nobody has observed you performing that operation, he should not realize that that operation has been done. Means the cube should look exactly same as before. That's called symmetry operation. Okay. Now we'll see. Right? Cube has about an axis, about a line. How many different symmetry aspects are there in a cube? We'll see. Okay, so like this again, we have to draw one more cube. Okay, so one more cube like this. Okay, this is a cube. We have seen about point. About from a point in what ways cube is symmetric, point center of inversion. About planes, how cube is appearing symmetric, planar symmetry we have seen. Now we will see axial symmetry, about a line. What is that? Right? I'll imagine one axis passing through the midpoint of the upper face, passing through the body center and passing through the midpoint of the bottom face. Okay, this is one axis. This is one axis I call. Now about this axis, if I rotate the cube through exactly 90 degrees and leave it, okay, right, the cube appears same as before. If you have not seen me rotating the cube, sorry again, okay, if you have not seen me rotating the cube, you will not realize that I have rotated the cube. Okay, cube appears same as before. Okay, I can show you practically. Say, please give me that book. Please give me that book. Thank you. Okay, say, though this is not a cube, imagine this is okay, right? This is a cube, I say. Think that it is a cube. Now, my axis is like this, passing through the midpoint of the opposite face, passing through the body center and coming out like this. About this axis, now imagine me rotating the cube exactly through 90 degrees. Okay, if it is really a cube appears same as before, just like a matchbox you take. Okay, you rotate it through, though it's not a cube, you rotate it through 90 degrees. If it is a cube, right, you will not realize that I have rotated. Okay, Means one operation. What is that operation? Rotation. Rotation through what angle? 90 degrees, not 75 degrees or 95 degrees. No. Okay, you have to rotate exactly through 90 degrees only, either towards left or right towards. Okay, right? What happens? Q appears same as before. Okay, right? Now 360 degrees by 90 degrees is equal to 4. That is 360 degrees by theta equal to n, I will write. Okay, I'll write one formula here. Now, I rotated once through 90 degrees. You have not seen me rotating, so you will understand, right? You will not understand that I have rotated. Again, I will rotate it through 90 degrees. Okay, cube again appears same as before. This time also, you will not realize that I have rotated. Now, totally I have rotated through 2 times. Each time through, how many times? How many angle? How much angle? 90 degrees. Again, like that, I can rotate it once more. Okay, through 90. I can rotate it once more through 90. Like this, how many times I can rotate? Every time I have to rotate through 90 degrees, right? Like that, how many times I can rotate to complete one revolution? 4 times I can rotate. Okay, 360 degrees by theta equal to n means this axis has having 4-fold symmetry. Okay, this axis is known as 4-fold symmetric axis or tetrad axis we call it. Tetrad, 4-fold. Okay, 4-fold axis of symmetry. 360 degrees by 90 equal to 4 means 4 times you can rotate the cube. Each time through 90 degrees, the cube appears same every time. Okay, you will complete one revolution. After that, it is simply repetition. Okay, right? Now, so this is known as 4-fold axis of symmetry or tetrad axis we call. How many such tetrad axes are there? Okay, now we have to count how many such. Right? I can rotate the cube about this axis like this. Okay, that is understood. That's what we have seen. Now, is this the only axis I can rotate the cube like this? This is also an axis? No. Imagine this is a cube. I put the axis like this and I'll keep on rotating the book like this. 90, 90, 90 like this. This time also, cube appears same as before. Means this is not the only tetrad axis. Tetrad axis can be like this also. Okay, you can rotate the cube like this. You can rotate the cube like this. Each time through 90 degrees, 4 times. Each time through 90 degrees, 4 times. And one more from the front axis also, it is like this. Okay, about this axis also, you can rotate the cube like this. Every time 90 degrees, 4 times. So, this one, this one, this one. Totally, how many tetrad axes are there in the cube? 3 tetrad axes are there. Okay, that number is important to us. So, number of tetrad axis equal to number of tetrad axis is equal to how many? 3. How many? 3. What is a tetrad axis? By definition, 360 degrees by theta equal to n. Tetrad means 4-fold axis of symmetry. Put n equal to 4, you will get theta equal to 90 degrees. Means we should understand that every time I can rotate it through 90 degrees. Like that, I can do it 4 times. The cube appears same every time. Okay, you will complete one revolution. Okay, so this is one more symmetry aspects present in the cube. Okay, next one. This time 360 degrees by 120 degrees I do. 360 by 120 degrees equal to 3. That is theta equal to 120 degrees, n equal to 3. This I call it as 3-fold axis of symmetry. Okay, 3-fold axis of symmetry. Okay, each one is known as 3-fold axis of symmetry. Okay, or triad axis I will call it. Or triad. Okay, triad axis. Okay, what is a triad axis means? This is somewhat slightly difficult to show. You have to have some realize. Okay, you have to close your eyes, imagine a cube and try to realize. Okay, right? Even you have to put some effort here because these are all 3-dimensional structures. Everything cannot be clearly shown on the board, especially not all. Okay, and I'm one of them. Okay, right? So, what is that? 3-fold axis of symmetry means, okay, that line passing through the body center and passing through diagonal opposite corners. Okay, diagonal opposite corners means it is this line, or imagine I cannot draw it actually, it spoils the figure, right? One line passing through this edge and this edge. Now, you look at this edge, right? Look through that edge. Along the axis, if you look, the picture will be looking like this. Means you will be seeing 3 edges here. Axis is passing. The cube is lying on one corner. Cube is lying on one corner. Okay. You are standing it, making it stand on one corner. You are passing the what you call the axis through one corner, through the body center, through the diagonal opposite corner. What do you call this line? This line is nothing but our body diagonal. Okay, body diagonal. Okay, right? Along the body diagonal, if you see, the cube will be looking like this, and these angles are 120, 120, 120. Now you rotate the cube about the corner by 120 degrees, the cube appears same. The cube appears same. Okay, means this edge will come here, this edge will go there, okay, this edge will come here. Right? So body diagonal is known as a threefold axis of symmetry. Each time you have to rotate it through 120 degrees. Like that you can rotate it 3 times in order to complete one revolution. What is that axis? Axis nothing but body diagonal, remember. Now, how many such triad axes or threefold axes are possible? How many such a triad or threefold axes are possible means, now body diagonals. How many body diagonals I can draw in a cube? How many body diagonals we can draw in a cube? Okay, right? Now, you observe here, for each body diagonal, you need the help of 2 corners, 2 diagonally opposite corners. Okay, this body diagonal will be like this. Means this needs help of this corner and this corner. Like this, from this corner to this corner, from this corner to this corner. Okay, there are 8 corners in the cube. Each body diagonal is taking 2 corners. So, out from 8, you can draw 4 body diagonals. 4 body diagonals. Okay. Along that body diagonal, the cube will be looking like this. Each time you can rotate it through 120 degrees. You can just take any cubic structure, make it stand on one. It won't stand on one corner. Just make it stand on one corner and try to, looking from the top, if you see that 120 degrees angle, you can visualize. Okay. So this is threefold axis of symmetry. 360 degrees by n equal to theta. When n equal to 3, theta equal to 120 degrees 3 times. How many such triad axes are possible or threefold axis of possible? Right? 4 body diagonals means 4 triad axes are possible. So the number of tetrad axes is 3. Number of triad axes will be 4. Number of triad axis. Okay, number of triad axis is equal to 4. We write. Okay, number of triad axes are 4. Next one, 360 degrees by 2 you do. 360 degrees by 2, if you do, you will get 180 degrees. Okay, what does that mean? Each time you have to rotate the cube through 180 degrees. Okay, like that, how many times you can rotate to complete one revolution? 2 times. Means 2 times you can rotate the cube through 180 degrees each time. The cube appears same as before. Like that, you can do only 2 times. Okay, 360 completed, one revolution is over. So what do we call this one as? Twofold axis of symmetry. It is known as twofold axis of symmetry. Twofold axis of symmetry. Right? What is the angle through which you have to rotate it through? 180 degrees. Okay. Right? Now, imagine an axis passing through the midpoint of this edge. Okay. And passing through diagonally opposite edge. Okay, an axis passing like this. Okay, an axis passing like this, or I can roughly show you, even though it is not a cube again, I'll imagine that it is a cube, there is one axis like this. That axis is passing through the midpoint of this edge and coming out of the midpoint of this edge. It is going like this. It is going like this. Okay, imagine that. Now, the cube is looking like this. Now I have to rotate it in order to make it appear same as before. What angle I have to rotate? Okay, I have to rotate it through exactly 180 degrees. Okay, if it's really a cube, right, it will look same as before. Okay, an operation called rotation through 180 degrees is leaving the cube. Invariant we call. Okay, an operation through 90 degrees, if the operation through 90 degrees leaves the cube invariant, okay, it is known as tetrad axis. If an operation through 120 degrees leaves the cube invariant, it is known as triad axis. If an operation through 180 degrees leaves the cube invariant, invariant means it should look same as before. It should be same as before. Okay, right? That is known as dyad axis or twofold axis of symmetry. How many such axes are there? Now we have to see. Okay, this is one dyad axis. An axis passing like this, coming out like this, and you are rotating the cube about this. So every time you have to rotate through 180 degrees. And again, one more 180 degrees, the cube comes back to its original thing. Okay, now how many such dyad axes are there? Again, can you look here carefully? For one diode axis, right, I am taking the help of this edge and diagonally opposite edge like this. Okay, twofold or diode, D-I-A-D, diode axis. Okay, for one diode axis, I am taking the help of two edges, diagonally opposite edges. Totally, how many edges are there in a cube? 12 edges. So, how many body diagonals? How many diagonals? How many diode axes I can draw? Okay, 6 diode axes I can draw. So 6 diode axis. So number of diode axis, number of twofold or diode axis of symmetry is equal to 6. I will write. Is equal to 6. We will write. So a cube has now totally how many symmetry elements are there? Cube is symmetric about some planes. Cube is symmetric about one point. Cube is symmetric about some axis also. Okay, these are all symmetry aspects present in a cube. Okay, totally how many symmetry aspects are there? Number of diode axes are 6. Okay, number of triad axes are 4. 6 plus 4, 10. Okay, number of triad axes are 3. 10 plus 3, 13. Okay, number of diagonal planes of symmetry 6. 13 plus 6, how many? 19. Okay, right? Number of bilateral planes of symmetry are how many? 3. 19 plus 3, 22. And 1 center of inversion. Okay, totally there are 23 symmetry elements present in the cube. Okay, totally there are 23 symmetry elements present in the cube. Total symmetry elements present in the cube. Okay, cube system of all the 7 crystal systems we have seen in the very first class of crystal structure. We have divided crystals into 7 crystal systems. Cubic system is the one which is having maximum number of symmetry elements. 23 symmetry elements are present in the cube. Okay, now you may ask me, sir, why are we studying all these things? We are not small kids, no. Why should we take one cube and see about this axis, it appears same or not? Okay, about the body center, so what it is. Okay, the symmetry aspects play a very crucial role in determining the properties of crystals. Okay, right, properties of crystals, right? Now crystals which are not having center of inversion, okay, crystals which are not having center of inversion only show a property called piezoelectric effect or piezoelectric effect. Some people call piezo, some call piezo, anything is okay. Okay, piezo means what? Pressure. Okay, piezoelectric effect means you apply pressure on the crystal in one direction, in a perpendicular direction, electric potential difference will come. Okay, that's known as piezoelectric effect. Or if you apply electric field in one direction, along the perpendicular direction, mechanical effect means the cube will either get compressed or expanded. Okay, that's known as inverse piezoelectric effect. Okay, that's known as inverse piezoelectric means you apply pressure on a cube in one direction, potential difference will come. That is what is the concept used in our what you call cigarette lighters or even our gas stove lighters also. Okay, any lighter works on that principle only. When you are pressing that knob, okay, so one spring gets released and one sharp needle-like thing goes and there was extremely small crystal, along one specific direction it goes and hits. Okay, right? Just like a sharp edge goes and hits the crystal. It creates a lot of pressure. Okay, because of the pressure, potential difference will come. Right? In the tiny crystal, right, what you cannot even see. Normally, you cannot even see with our naked eyes also. That small crystal will be there. Okay, one very small needle will go and hit it. One very small spark will come. Okay, that spark, if it is present in what you call gaseous atmosphere, LPG or LPG, what you call or butane gas or CNG gas, it starts burning. One spark is sufficient. Petrol also, but okay, it starts burning. Okay, that is what is used in our gas. Right? We are not wasting mass sticks. Okay, so imagine 130 crore people having at least 30-40 crores of houses. Okay, in each house, right? Every day some 10-15 mastics are being used. Means how many crore mastics, how many trees should be brought down. Okay, now we are avoiding that because we have understood the property called piezoelectric property. Okay, it is environmentally clean. Okay, we are saving many trees. Okay, we are not wasting any trees like this, right? So that is, and where what happens, right? When this needle goes and hits that crystal there, a potential difference of nearly 17,000 volts gets developed. Okay, in the crystal what we are using as a gas stove lighter in our houses, in our kitchens. Okay, 17,000 volts potential difference will be generated. And air loses its dielectric property. Dielectric strength of air is only 3,000 volts per millimeter. Okay, here that less than 1 millimeter crystal is getting developed. 17,000 volts is getting developed. So air loses its dielectric property and starts ionizing the gas. Ionizing, it starts passing. It is no longer a dielectric. So what happens? A conducting path will be created. One spark will be produced. One spark will be produced. Okay, right? That spark, if it is in gaseous, igniting gas like LPG, it will burn. Okay, right? Which crystals? Not any crystal we see on the road can be used as what you call that crystal. Okay, only piezoelectric crystals are useful. Okay, only piezoelectric crystals are capable of what you call behaving like that. They show that piezoelectric property. Which crystals show piezoelectric property? Here there are 1500 crystals. Okay, which crystals? There are thousands of crystals available in nature. Those crystals which do not have center of inversion. Those crystals which do not have center of inversion will show this property called piezoelectric effect. Okay, right? Now what about this cubic system? Cubic system has center of inversion. Its body center itself is center of inversion. No. So you take any cubic crystal, you do whatever you want, right? You apply pressure, what you call apply pressure in any direction like this, it will not show piezoelectric effect. No potential difference will come. Or if you apply potential difference, no mechanical compressions and extensions will be happening. Okay, right? So all cubic structures we have seen, silicon, germanium, all are cubical, diamond, etc., whatever you do, right? They are not useful as piezoelectric crystals. Only crystals which do not have center of inversion will behave as piezoelectric crystals. Okay, a special case of piezo is pyro. Okay, pyro means even if very small amount of radiation falls on it, even if you change the temperature by 0.0001 degrees Celsius, there will be a small pyro means heat. Okay, fire. Right? A small potential difference will come. That potential difference of our electronic circuit, that 1 microvolt potential difference or 0.1 microvolt potential difference of our electronic circuits will immediately amplify to 100 volts or 230 volts. Okay, one burglar alarm will start what you call ringing. Okay, pyroelectric effect is we don't have to heat it putting on a stove. Okay, just go in front of the crystal. Our body will be emitting, right, infrared radiation of 1,50,000 angstroms roughly. Infrared radiation property is to provide heat. When this body goes and the radiation of this body, human body radiation, goes and falls on the crystal, its temperature will change by 1/10,000th of a degree Celsius also. A very small potential difference will come. Immediately burglar alarm or some thermoelectric effects with thermal effects will be activated. Okay, I can take a photograph, I can take make an alarm, make sound, etc. Okay, right? That's pyroelectric effect. These pyroelectric effects are used as guiding, okay, for guided missiles. Okay, missiles are guided, right? They are like thermal image scanners. Okay, right? They are used in that aspect. Next one, if there is some more special property like the electric dipole moment can be reversed in a pyroelectric effect, it becomes a ferroelectric crystal. Okay, it becomes a ferroelectric crystal where we use something like barium titanate or PZT crystals, etc., which are used in small sized high capacity capacitors. Okay, those things will be clear once I go into dielectric material. But this is our foundation actually. There will say simply crystals which are not having center of inversion or piezoelectric in nature. We don't discuss all these things here because we have already discussed in our cubic systems. Okay, right? Thank you. The next topic we'll see in the next video. Goodbye.